The definition of the database and the technology that the database and the data store, the database management systems provide to deliver remote services. All we saw in the first security, we discussed it was the physical security. We discussed the context of the relationships to be available within one database amongst the entities. This is actually another context of security that we may think of whenever we talk about securing the service delivery using a data store in background, which is the context of the encryption. We are not discussing the security of the databases. We are discussing here the delivery of services, whatever they are, resources or functions from a remote, let's say, destination, or whatever the network is. So the database encryption, it is one of the solutions to secure what we deliver using a database in background. We encrypt either the content of the database, or the data being submitted, the media transmitted over the network or whatever, the shared media, retrieved or requested. Actually, either it is the request being submitted to the database or from the database. Here, actually, the context of the encryption is a scenario. We may apply it from different perspectives, and there are rules for that. But it is one of the good solutions to secure a remote service delivery, and specifically and more precisely when we talk about the use of a database, a project that it is standing on using a database in background. The encryption, it's the solution of is the scenario of using, let's say, generating cipher content, let's say, where we cannot actually, if any injection or interception that happens, we'll not be able to read the content. We'll not find the clear data at the end being exposed. No, things actually it is a cipher context or cipher content. The encryption, remember that. So however the scenario is being happening, it is something that cannot be read or understood by the human being. The encrypted content, it is not something to be intercepted. There are scenarios we discussed, actually, the brute force and the dictionary attack in more than one place when we talked about the cybersecurity definitions. The chapter number 2, I believe, the cryptography. The same scenario applies here. But we talk about a data store content to be secured, or the retrieved or the submitted request to the data store to be encrypted. Simple. Okay, we pass to the second part of this unit, which is the context of the cloud computing. We were discussing on the first part so far the context of the databases and the data stores to terminate or to use as a service, let's say, focal point. It is one unit. All what we saw, if you remember very well the context of the relationship, it is the relations that happens in between the entities amongst or within one database. It's a one unit. We are going to see in this part here something a little bit more vast. Same definitions will apply still. We have to talk about the security of service delivery. We are talking about a remote service to be delivered, but in another view. The context, the first definition actually to be given to the scenario of a cloud computer. I'll come back to this slide here. I'll come back because I need it just to make you retrieve, or let's say conceive, the definition of what is a cloud computer. It is sort of different or variety of services to be delivered remotely, dedicated to amongst the request or the need of the end users. Services to be delivered remotely. At the end of the day, we are not talking about something new with a different architecture, yes, but those services, they are going to be delivered amongst the need of the clients, whatever the client is requiring here. For example, if you can see where I'm pointing now, whatever service number one or request number one, whatever the purpose or the need number one, number two, and so on. Amongst of that, there are dedicated solutions in background delivered upon different architectures accordingly. Services they are available, but whenever you need, you'll find wherever also you need, you'll find the solution, and so on. So this is the context of cloud computing. It's another way, it's another architecture via which we see the services being delivered remotely. But here, it is a continuation to the first part of this chapter, which is the database security. Why? Because still we'll stand on the same definitions we saw so far, but we are seeing the thing a little bit more vast. We are not talking about one unit. We may find, here it's not we may find, actually, we clearly see the definition of the distributed systems, which we defined also, being visualized here. Means we see more than one entity, or more than one unit, all together working together to accomplish one service or one system. Computer number one, computer number two, network number one, network number two, number three, and so on. All together they are working to accomplish one service delivery, or one project, only one unit, one entity. At the end of the day, one final product. It is the briefest explanation we can see regarding the context of the cloud computing. What is it? Again, this famous standardization unit body, it is actually given us the this definition what we saw, what I just was discussing to you regarding the definition of the cloud computer. It's the standard view of what is a database, of what is a cloud computing. When we say it's a model for enabling ubiquitous and convenient, and also the more persistent, given on demand network access, actually, to whatever is the resources. It's a definition given actually through a standardized view by this body. The NIST, by the way, can you tell me what is this NIST? If you remember very well, this is the first standardization body we defined, chapter number 1, when we talked about the cybersecurity definition. The NIST stands for what? What is it? What is it? Can you give me a briefing on that, please? Are you able to provide any feedback? National Institute for Standardization and Technology. It's a United States actually settled body, where it is internationally recognized as a body for standardizing security and digital security and cyber security and computer security rules and, let's say, policies and standards. So this body, the same, it is given the definition of this. What is this cloud computer? It's not the unique definition you might find if you open different books, but all of them, they are around this definition. They will not say that this definition is a little bit different or it's not considered. No, they will extract that definition from this given here. Regardless, so the briefest graph via which we see the cloud computing in action here is the one we see in front now. At the end of the day, we are having an architecture via which we find the services are delivered, or are spread or are stored. In the sense of, when we talked about the distributed systems, or when we talked about the let's say, versatility and the variety of service, or let's say the segregation of one service in a geographical area, there is an architecture. How they are, the nodes accomplishing one service, how they are connected all together in order to finish one service. We talk about architecture here. It is the model. It is the model here of the cloud computer. This model here, whatever the model we'll discuss a little bit later, but whatever the model is, there are services in that model. There are services to be delivered, services in plural. The services, they are actually to be available for whomever requests. The users, they would request service number 1, service number 2, service number, and so on. Those services requested by users, and those services, they are stored in a cloud computing network, or let's say environment. And this network environment, cloud computing, is based on architecture, a model. You can discuss it this way. Any questions, please? try to interact, please listen to me carefully, and if you have any questions, you may ask, you may raise them up. Okay. We have to recognize that there is actually an added value here. There is an added value. There is an AOD related to the use of the cloud computer, because you may say, okay, I'm going to use only database-based project, and that's it. Simple. Full stop. Why I have to know this new technology and how to segregate the functions, or let's say the utilities required to build up this cloud computing environment and later on provide it to users and so on. Why this mess, kind of mess, let's say? Why we are adding complexity? No, the answer is not. It's not complexity. It's not a mess at all, and it's not a complexity added, but it is another resilience, we may say, to deliver services more securely and more, let's say, fluently to the end users. It's an added value. It's not a complexity. It's not a difficulty to be added. It's another view for a better service delivery. Thus, we talk about the characteristics here. The first actually characteristic we have to stress on is that the access to broad networks is possible through the cloud computing, in the sense of you can use your mobile to access the resources I give you here through my, let's say, desk computer. I can give you access, and you can access those resources using your own mobile. What is your mobile? It's actually an iOS-based mobile, or it's an Android-based mobile, or it's an Huawei-based, whatever the platform you're using. It would be actually able to access the resources I give, because it's not trivial. It's not something that by consequence you'll find it easy to do. No, but the technology enhances that, and this is one of the very famous characteristics when you talk about cloud computing. Actually, the broad network access, in the sense of they are not non-heterogeneous and they are very far. Broad network access. Actually, this feature, this characteristic, is enhanced by the cloud computer. When we say that you use your mobile to access the resources I give you, I did not set the resource to be opened by the mobile, but still your mobile can open and access the resources I give you. Why? Because the technology enhances that. This enhancement here is one of the characteristics that the cloud computer provides to you. So the availability anywhere and anytime here is fulfilled by this broad network access. Moreover than that, actually, our group here is made up of 60 students, or whatever the number is. If we increase the number of students, are they still be able to, let's say, given the access to the same resources? We are going to add 10 more students, or we are going to add 100 more students, let's say. Are they still capable to, will they be able to access the same resource? The answer is yes. We talk about the elasticity here, is the resilience, in the sense of we can increase the number of users for the same resource using the same bandwidth, the same access, let's say, path. It can give you, actually, there is a solution how the cloud computer can solve this issue. The same way, as we increase, we may diminish. It's not only to increase the capacity of the number of users. No, we can actually also, let's say, reduce. Diminishing fact can be also supported by the cloud computer. So whatever, we talk about the elasticity here, or the resilience fact. So it's another characteristic that the cloud computing do support. When we say that you are going to access the resource anywhere, anytime, does not mean that you are going to use any service usually and frequently. No, this is actually something measured. Means whatever you need, you'll be also accessing as a service available. Let me come back to the graph. As a service, whatever the service is, we discussed the services. Whatever the service is available in cloud, if you are not using as an end user, it is not consumed by you. It is far away from you. It is not counted on, let's say, your account or something like that. So there is a measurement of what are the services to be utilized, what are the services that have to be delivered to the end user, no more, no less. So the cloud computing is not, it is counting what you are requiring, and it measures the services to be delivered to you, no more, no less. Yes. So the service, they are available within the architecture, within the cloud environment, cloud network, but you are not going to receive only what you request. So the service will be automatically given to you based on your request, you as an end user, consumer. Yeah, it is actually the fact of the on-demand service delivery means the cloud computing, when it does an automatic, actually an automated measurement of what other services required by you. So it is an on-demand service behavior, act, or function. You need to open, let's say the examples of the Google Docs. If you are going to use the Google Docs as a service, the slides I'm using now, actually, it is delivered to you online, and they are opened by the Google service as PowerPoints from the Google itself. So this is actually one of the examples, the on-demand service delivery. I'm counted using these PowerPoints only. I'm not using the other Google services. So this is an example of on-demand. You may see it this way. So based on the time of use and the platform using, so it's an on-demand service. It's one of the characteristics that the cloud computing can control, can measure. Means if I close this let's say this presentation, خلاص, the service has been terminated. I'm not gonna be charged more than what I used. Simply on-demand service. So there are measurements to be done based on the request also. Yeah, the context of those on-demand services and the measurement of those services to be delivered. I'm here in Nizwa now. Actually, I'm in Sultanate of Oman. If I move to Dubai, for example, UAE, or if I move to the United States, will I be using the same service if I request? Absolutely, yes. So I will be using maybe the same account, the same user account. If you notice here, my ID here it is the same account. Yes, maybe I will be using another account, maybe also. But in all cases, there is a characteristic, there is a feature that the cloud computing do go beyond, which is the pooling, the scenario of the pooling. Actually, it is a matter of management of tenants, the sessions, what you are going to request from where. If I'm asking to open those slides here in Oman, it will give me the nearest service to me since I'm asking. If I go to the United States, it will give me maybe not from the same source, but the same service. Again, if I'm using the same session, I'm authenticated here, I will be authenticated there also, the same way. There where, and then if I'm accessing through a different geographical location. So we're talking about multi-tenant. Let's say it's a context of authentication here. Okay, the kinds of if I come back to the graph here, the services we deliver here, the kinds of the types of the service we talk about, they are based on the request usually, but we talk about three types mainly, three types of services. They are actually the software as a service, like we talk about here in this example here. We talk, if you want to open the PowerPoint, what is the PowerPoint? It's a software I'm using. It's an application I'm using to deliver you a presentation, something like that. So it's a software to be delivered as a service. It's a software to be delivered as a service, no more, no less. Whatever, PowerPoint or any other computer program. Yeah, not only that. We may talk about a platform as a software. PaaS, PaaS, platform as a service, in the sense of what are the platform? Actually, the first thing we may think of is the operating systems, the list of the operating systems, whether they are client operating systems or server operating systems. They are all considered to be a platform where software applications run, where services being also run, and so on. So the platform, it might be required. If we take the example of our context, the cybersecurity, we may talk about dedicated platforms to cybersecurity tasks, like for example, the one we installed in the virtual lab, actually in the first class, if you remember very well, the Kali, or the dedicated customized operating system, Windows based. All of them, they are considered to be platforms where we can find, which we can find actually, they can be delivered to us as a service over the cloud platform as a service. Uh, more than that actually, because the platform needs peripheral to run on. The application needs a platform to run on. Those platforms, the peripherals required here to, for example, to install the Kali, it's not the same specificities required for Windows. It's not the same specificity when we talk about a dedicated operating system as a server. So we talk about an infrastructure. Even the hardware can be find as a service delivered in on the cloud. So here we talk about the infrastructure. Yes. So the virtualization we did in the lab here on campus, we can find solutions on the cloud also. Yeah, absolutely. Same context is to mimic the real case, but in a remote destination, a remote, let's say remote environment. The totality of the hardware, we can mimic it. We talk about the infrastructure regardless. So yes, the models we discussed, the models we were talking about in the cloud here, the four of them, they are architectures. How, let's say, this cloud computing is acting towards the requests and the responses to the clients. Yes. Whether we talk about the four of them here, I'm going to just define them one by one. The first model, which is the public view, the public cloud environment, where we can see everything is delivered to all, everything in the sense of the services to all the users. So all services available within this cloud is delivered to all any request whenever it's submitted, general public here. The second, which is a complete controversial case, which is the private one. Nothing is delivered unless it is authenticated. It is being authenticated with the consent. Services still they are available. Still, we talk about the services available with this dedicated cloud only, this environment, this workplace. And it is being delivered unless it is being authenticated and consented solely for an organization. We may say that like that, but whatever organization, it is manifested through the users. No, we will not find a body as an organization working. No, we will find a request from a candidate, something like that. So will not be delivered unless it is being authenticated solely here for an organization in the sense of being authenticated. Communicated is a dedicated environment. Community, sorry, it's a dedicated environment. In the sense of talking about the University of Lisbon platform, for example, as per an example, unless you are authenticated within the UNISWA email only, will be awarded an access. If even you are registered somewhere to any service with the University of Lisbon, if you are not using the UNISWA ID, you'll not be able to access. So this is a kind of a community dedicated cloud computing environment. So dedicated framework, as per example we discussed. Hybrid, we may find a mixture of those three: the public, the private, the community, or mixture of two only, public and private, mixture of public and community, something like it's a mixture of different kinds of the models we discussed earlier: the first, the second, and the third. A hybrid, it's a mixture of that comes between those three here. A typical cloud actually serves context. Here we may actually, it's a very good example here where we see the service being delivered. A back end where the services are. The services, we saw three services here: the software as a service, the platform as a service, the infrastructure as a service. Whatever the service is, there will be actually media of transmitting this service. The very famous media, which is the internet. And more of that, actually, we might find actually an end user, or let's say an end consumer. The end consumer here, just one note to bring it to your attention, is that the end user can be a network, not only a user. Many sense. If we want the University of Lisbon here to request, for example, the context of registration of courses, we may award a service from the cloud to all the users of the University of Nizwa, let's say, network. So University of Nizwa users, they are hundreds or thousands maybe, they are all awarded the access to the same service. So the end user is whom? The list of the users, the candidates, authenticated by University of Nizwa. It's a list of users. It's not one user, but they are accessing the same resource. So it's here with this graph, you can see actually the access to the service, whatever they are, amongst actually a cloud computing architecture, whatever. Any questions, please? Immediately, I'll pass to you one last context, which is the context of the provider, scenario of a provider. When we discussed the services, SaaS stands for software as a service, PaaS stands for platform as a service, IaaS stands for infrastructure as a service. We have to talk about who is a provider, because we may find actually a cloud provider, cloud computing provider, that does not provide all the services. Yes, we might find only a software as a service provider. Yes, it's a company that provides only this kind of service. Another company that provides only this service, and so on. So it's not mandatory. Those are the services, yes, but it's not mandatory that any provider, cloud computing provider, they have to provide all. No. We may find, yeah, they are dedicated to this service only, for example, or this service only, or this service only. So what they are doing. So this is the context of provider. Thus, to say, for example, they are software as a service provider, they have to have the required platform running in order to provide such a service. We cannot talk about a company that has actually physical infrastructure and delivers software as a service. They do not have the adequate platform, we may say that. So based on that, we specify the service to be delivered. Based on what? What is that? The availabilities, either this or whatever. What are the facilities they have? What are the expertise they do provide? Based on that, the service is described. At this point, any questions, please? Boys and girls, any questions, please? Muhammad, any questions, Muhammad? Okay, we continue. As per this, actually, now you have, based on this only, you have a very good view and understanding of what is this context of cloud computer. The context of the security sector towards the cloud computing is the scenario of the very famous actually security issue, as we discussed for the database, the injection. Here for the cloud computing, we talk about the abuse, the scenario of the abuse. What does mean abuse? Well, in the sense of, we're going to, because remember, the cloud computing is something actually segregated amongst nodes, whatever the service or the requests or whatever, it is something segregated. So the access to the resource requires multipath, something like that. An interception might happen for a reason or another. For example, we talk about the DOS or the DDoS as a context of attack to one of the entities or to all the entities used to accomplish a service. So the compromisation of a service, or let's say an entity or a part of a service, can lead to an abuse, which is either you give, let's say, a ransom, or you'll not be having an access to your resources again. So this is one of the issues that the cloud is facing usually. So the security towards the cloud, the first thing to think of is to secure the content from such an attack. Means if there is any interception, any interference, any interception, yes, man-in-the-middle attack, there have to be a solution to trespass that, to avoid the abuse, because if we have only one database, and this one database has been compromised, there is no other solution unless you have to pay for the abuse. But if you have a duplicated copy, a mirror copy, you may say, technically speaking, will not fall in this case. Never will find. If it is being compromised, we'll completely delete it, and we'll have a second copy of that. It is already available. So it has been avoided. Yeah, so this is the context of the abuse, but even though there are scenarios how to implement the countermeasure of the abuse, because you have to know the abuse of what. But usually we talk about the interception or the data compromisation. Yeah, we discussed the inferences and the interception. Yeah, one of the very famous issues also, it's not the most, but one of the very famous issues towards the cloud computing is the context of the insiders. Remember that not all the organization works, they are experts in IT or in information systems or in computer science. They are not. We find administrators that they do not have the technical skills to deal with the computer programs. They are not technical people, they are administrators, administrative people only. Because of their lack of awareness, they are considered to be malicious insiders because they do not know how to act with issues. They may give trust to hackers or to crackers or to any outside parties. They will give them access without any consent or without any paying attention. So they are malicious insiders. They do not intend to do, but because of their lack of awareness, they do open access ports or points or let's say entry paths to the externals, which they can use to compromise the resource. Insiders, remember, malicious insiders. Okay, this way actually I'll stop this explanation here at this point. And by this we finish this context of the database and the cloud computer. And I'll stop the recording also, but unless you have any questions, please raise them up. Otherwise,